All right, let's dive in here. So let me share my screen and we'll have to collectively, hey Adam, we'll have to collectively refresh ourselves on where we were last time. So if, let me make this slightly bigger. Okay. So if folks can recall, we were in the process of kind of doing this extended work on our actors example. Adam, I see you raised your hand. Do you have a question you want to type in? Okay, if you do have a question, yeah, just type it into Discord is probably best. Okay, no worries. Yeah. So basically, we were working through this actors example, and so we started off with just kind of basic Zio actors, which I think is kind of like a less than one session thing. But then we were interested in exploring how we could make them distributed, and so we were in the process of doing that, where we had this concept of each node. Let's kind of imagine as each machine, though I think we'll kind of start up multiple nodes on my computer. But each node is going to essentially be responsible for a set of actors. And so when we use the actor system, when we interact with it and we basically do a call to the actor, if we say set the temperature or get the temperature, it's going to see if the actor is on this machine or on some other machine. And if it's on this machine, then it's just going to run the thing on the actor and we're going to be done. But otherwise, we're going to have this idea where it's going to call the machine that the actor is actually on. And we're going to know which one is on because we have this concept of the actor ID, which includes a location and a local ID. And the location is the host of the port that's on. I guess I should call this location instead of location ID. And then the local ID is more just like maybe this eventually will be a UUID, but it's basically just like kind of a unique identifier on that machine. So to do that, we kind of had two parts we had to do. We had to do like the client and the server part essentially. And so what we did last time before we had a little break for functional Scala and Thanksgiving was we did the server part. As well as actually the endpoints, which kind of powers a lot of this. So we defined some endpoints, and then we use that to implement this actor system service, which is basically the server logic here. And so it had these methods that took a encoded request and took the identifier for the actor and basically found the actor and decoded the encoded request and then used it to call it on the actor. And then if it was a send, you were just done because there's no response. If it's an ask, then once the actor did its response, we need to encode that and we need to send that back. And so these, I mean, there's some kind of complexity in the implementation, but these ultimately are just basically functions here, right? You look at the send, it just kind of takes two inputs, and this one just returns unit. This one takes two inputs and it returns this actor response. And then we were just able to take these functions and in our actor server here, we just took our endpoints, which were kind of descriptions of these endpoints, and we just implemented them by calling handler on those methods. And because the signatures of the methods lined up with the signatures of the endpoints, right? You see like this one accepts a local ID and an actor request and returns unit. This one accepts a local ID and an actor request and returns an actor response. We were essentially, the compiler was making sure those things lined up for us. And so, right, if we look at the actor system send, let me actor system service send, we see that it takes the local ID and the actor request and returns unit, and those types match up, and so the compiler is happy with us. So the this kind of gives us a nice like typed way to define our server. And so what we have left to do at this point is basically two things of we need the client side of that one. So if we go down here, we have these two question marks, which is basically handling the case where we've called on the actor system, right? The actor system has given us this actor ref, and we've called send. And when we look in this actor system, we say, oh, we're not the ones who are responsible for this actor. So we've instead got to make this remote call to invoke the actor on whatever system the actor is actually on. And right now, these are just question marks. And essentially what this is requiring us to implement is the client side of the endpoints versus the server side we implemented before. So our first big thing is basically implementing that. You call it like an actor client. And then the second thing we're going to hopefully be able to do is once we have those two things, we should theoretically be able to actually have a interaction between remote actors here. And we should actually kind of set up a demo of that, and hopefully we can get the demo working. And as we do that, we may find we had a bug somewhere or what have you. So I think those are our two big goals for today. Before we dive into that, I'm going to do just a little bit of cleanup, which you may remember we had this kind of ugly type here, this like ref of a map of a local ID and an actor and these three schemas. And I think I'm not going to like spend a ton of time on refactoring, but I'm going to try to at least create kind of a one like class to just wrap this up to make this a little bit nicer here. So I think I'm going to create something. Maybe I'll call it the actor state. And by the way, as I'm going here, please feel free to jump in with any questions. Probably the Discord is the best way, but if you want to raise your hand or do anything else like that, or use the Zoom, just whatever, however you want to get the message to me, I'll take it kind of rain or snow. Okay, so Dominic, I think you are in the wrong Discord channel. And let's just read your question. Should the ask endpoint really give back an actor response and not an option? An actor, you need to be sure to get a response as the receiver decides if he wants to answer or not, or maybe not answer at all if he crashes. So at least in the way we've set it up now, the actor basically is always responsible for responding. Maybe they just want to give a responsive unit. Maybe they do give a failure and you get that failure back. But what we're essentially saying is, I mean, the actor is basically this function here. And so if you look at kind of the signature, like, no, if you send it a message that expects a response, you're going to get back a response. I mean, it may also give you some kind of die error, or the message or the response itself may encode an error. But there's not a possibility you're just going to get like no information. Maybe that could be a different way you set it up, but that's kind of not the way we're setting up here. Okay, so let me go back. I was just doing that one. Right, so I want to get rid of this thing. So I want to create this actor state thing. So let's just create a package for this. And maybe I'll just create a trade for this. Actor state, object actor state, val make. It's going to give us one of these things. And we can just do a for comprehension here. Say ref. And let's grab that giant type we had here. So we'll just make the ref here. And then we'll yield a new actor state. I'll get some auto compilation going here. We're going to need to import Zio here, as well as Zio schema, so it knows what a schema is, as well as our version of Zio actors, so that it knows what those are. Okay, so that is happy. So now here, I'm going to take this thing and I'm going to replace this with my actors. System.make. And we'll get a couple of compilation errors. Let's see. Oh, not actor system, but actor state. Excuse me. Okay. And so we see we had a get method and we had an update method. So we're going to need to add those on to this. So let's do that. So this, and right now I'm going to just kind of do a relatively minimal set of changes here, just so I don't have to refactor too much other code, but I kind of start hiding this. So we're going to have get, that looks like this. It's basically going to be ref.get. And then we'll have an update that just lets us change that. And it's basically going to be the ref.update. And then the only thing I need to do here is my actor system service requires this big ugly type, which now I can replace with my actor state. Okay, so now that's slightly nicer. And if I run my example, everything is working, so great. Okay, so let's now go on to look at implementing our, maybe we call it an actors client here. Or actor client, maybe. That's better. So let's call this actor client scala. And so let's think about what methods this would want to have here. So I think just like everything else, we're basically going to have these two methods of send and ask. And we basically want them to mirror what we have down here. So if you look here, we've got send, and we've got a message here, and we've got an actor ID from here. And we need to use both those pieces of information because the actor ID contains the location where this actor actually is running somewhere. So we need that so we can actually know where to make our remote call. And then we need the message because we need to send the message to the other server to have it actually process the message. So if those are inputs, then this can't be a local ID. This has to be an actor ID. So we're going to have an actor ID, and then it's not going to be a request, but it's going to be this message. And so this thing is going to be parameterized message. Doesn't care about the response type because it's not going to do anything with that. So this would be a message of any. And oh, I need to do some imports just so this makes sense. So import CO. Okay. All right, so let's start working on implementing this. So I'll use my usual pattern where we'll make this a layer. And so to do this, we're going to use something called an endpoint executor. And an endpoint executor is basically the way in Zio HTTP you do the client side of interacting with endpoints. So just like when, if we go back to these endpoints are just descriptions, right? There's no implementation on either side. This is just saying, hey, there's this endpoint that is a post and is actors and then expects a local ID and then expects a send and expects some information of this actor request. And so on the server side, the way we implemented this was with this endpoints, basically calling the .implement method on it. And that gave us a route. And then we combine these routes together with this routes constructor. And then when we have a group of routes, then we can just call to HTTP app, and that gives us a server. On the client side, the way we do it is with this endpoint executor. And an endpoint executor is basically a client, as well as possibly middleware, as well as what's called an endpoint locator, which is basically like what URL are you going to for these endpoints. So we're going to need to create one, and then we can use it to call our endpoints and have our client. So for that, we're definitely going to need a client. So I'm going to add a client as a dependency here. And I'm just going to access it here. And I'll bring in zio.http so we know what a client is. And then I'll start by just giving myself a question mark here. Oh, and I need a yield. Oh, and then I need just a Z layer constructor. Okay. Before I implement that, let me just do the other part of the interface here. So this is going to take a message that expects a response. Pulls a response, it's going to give us back the response. And so we just put this here. Let's see. Oh, I just need a question mark. Okay. All right. So now we got to implement these two things. So let's start with the send because it's simpler. And so the first thing we kind of need is we need one of these endpoint locator. And so I believe this is in the import co http.endpoint package. And so I can basically just do endpoint locator dot from URL, and I give it a URL, I believe. Yep. And so I can get the URL conceptually from the actor ID, because the actor ID has inside of it a location, and the location has inside of it a host and a port. But why don't I make that a little bit easier for myself? So let me go to this actor ID, and I could just give myself a little method here. Maybe I'll call this URL, and it's going to give me a URL. I'm going to bring in ZOHTTP. So I've got this. And I could do a little string interpolation here. And I could just say this is going to be like HTTP. And not this last part. I really just need the, so it's going to be HTTP, and this will end up, at least for me, being localhost and 8080 or whatever. With that, I think it's fine. And then if we go back to our active client, so then our endpoint locator can be actorid.url. So basically our local client needs to know where it's making a request from. So that makes sense. And then if we have that, we should be able to define an endpoint executor. And we can do that basically with this endpoint executor constructor. And if I remember the order correctly, I believe we want the client, then the endpoint locator, and takes one more parameter for any middleware we're using here, which we're not using any. So I'm just going to make that unit there. So now we've got an endpoint executor. And this endpoint executor is able to, if we give it one of these endpoints and we give it the parameters that the endpoint expects, so if we give it like a send endpoint and we give it a local ID and we give it an actor request, then it will actually go out and it'll run that call for us and will give us back the result of it. So let's see what that looks like. So I can do endpoint executor. I'm just going to use its apply method. So I can then do endpoints.send. And then I just do the two parameters to that. And that's actually going to run that endpoint for me. And in this case, it's going to give me back a ZO that returns what this endpoint returns, which is a unit. And that's what I need to return here. So I'm good there, I believe. Let's see. Oh, except I've got a scope here because whenever I make a request for streaming requests, I might need to close those afterwards. So I'm just going to do zio.scope here. Take care of that. And now I'm happy, except I need to give it these two parameters of the local ID and the active request, basically the encoded version of the message. And the reason that we need to do the encoding ourselves instead of just Zio HTTP doing that automatically is in this case, we're kind of managing this actor system where we have all these actors sending messages and they're all of different types. So we don't know the type of this at this level. So we need these schemas for that. So we'll kind of come back to that for a sec, but that's why some of this stuff is more complex than like if we were just implementing like a simple client server, like we wouldn't have to do any encoding or decoding ourselves. That would all be done by Zio HTTP for us. Okay, so the local ID is easy. That's just actor ID dot local ID. The actor request is a little harder because this is an encoded chunk of bytes. And we don't have a chunk of bytes. We only have this message. And at least right now, it looks like we don't have enough information to know how to encode it. And so this is basically the client-side version of the problem that we dealt with the last time when we looked at the server side of we basically need schemas for these things. So what I'm going to do here is I'm going to change this thing to require I'll call it maybe a request schema. And this is going to be a schema of a message of any. And I'm going to update this thing to also require the request schema, just so consistent. And I need to bring in Zio schema so it knows what schema is. Okay. And so now what I could do is I could do, let's see if I can do this. So I could do request binary codec, and we decided we're going to use JSON right now. We could change that or make that configurable, but right now we're going to use JSON. So I'm going to use Zio schema to create a JSON codec based on this schema for the request schema. And then I can use that codec to encode the message. And encoding can never fail. Decoding can potentially fail. So this is now going to give me a chunk of bytes. And then I could just stuff those inside an actor request. Maybe I'll call this actor request. Oops. Just see. And and I also need the import zio.schema.codec for the actual codecs. Okay, so there we have it. So I think that, so Dominique, you can't have a type that Zio schema doesn't know about because we have this schema here. You couldn't have created a schema for it without us knowing what those types are. Right, so I mean, imagine a concrete case where you have whatever your person data type. For you to have a schema at all, it means that you were able to, with Zio schema, derive or define a schema for it. So by definition, we know how to encode it. Okay, so let's do the same thing for ask now. So ask is going to be pretty similar to that. So I think I'm going to just start with this, the starting point here. And again, maybe I could factor out some of this logic of like the endpoint locator stuff, but I only have two methods. I'm going to feel a little bit of the pain here, and I can always refactor that later. And so let's look at what needs to be different here. So first thing is this is not going to compile right now because I need a schema for the request here, just like I did for send, which makes sense. And then here, instead of calling the send endpoint, I'm going to call the ask endpoint. But now I'm going to get a compilation error. And the basic problem here is if we look at the endpoints, this endpoint is returning an actor response, which if we look at an actor response, it's the encoded actor response, right? It's just basically a chunk of bytes. that this remote server has given back to us. But our contract is we are supposed to give back a typed response. So we have one more step that we need to do here. So basically, we need to do one more step, then we need a flat map. So I could call this an actor response. And so I need a way to convert this encoded chunk of bytes back into the typed response. And so again, this is just kind of the mirror of what we did before on the server side. And what we need is, in addition to needing a schema for the request, we need a schema for the response. So let's do that now. So in addition to a request schema, I'm going to have a response schema. That's a schema of a message of a, not even a message response, but just a response. And this is a message of a response. And then I need to update my type signature in the trait as well. Let's see, I think I just did something silly here. Oh, I think I know. This needs to be. There we go. Okay. So now we're happy here. And now we kind of have the information we do this. And so we're basically just going to do the other side of this. So I could say val response binary codec is equal to schema-based binary codec of the response schema. And then I can try to decode the value. And this time this could fail because I've just got these arbitrary bytes. So maybe they don't make sense for what the schema is expecting. So in this case, if they don't decode successfully, I'm just going to convert that to a die failure. And if they do decode, maybe I call this value, then I now have, or actually maybe I'll call this response. I now have the typed response that I can send back. So now we've got both the send and the ask implemented. I'm going to just do one more thing here, which is at least on my network, I've found I can have a little bit of flakiness when I just kind of call between different JVM processes on my machine. So I'm also just going to add a little bit of retry logic here, just so we're not dealing with that. So I'm going to call this maybe retry on connection refused. And this will just take any ZO, that's a ZO REA, and it's going to give me back a ZO REA. And so I can do ZO dot capital cause, give me a cause, and then I could do cause dot die option and match on that. And if I do have a throwable here, if the message contains connection refused, then I'm just going to retry on connection refused with that ZO. And maybe again, probably in other cases, we'd want to have more complex logic. We don't want to do that forever. But right now, I think that's going to be fine. So I've got that. And then I can just put that around these guys here, just so even if there is a little bit of flakiness, that's not going to show up to kind of our users or us in this case. Okay, so now we've got our client hopefully working. So let's actually plug that into our actor system here. So I think now this is, because we kind of did all the hard logic there, this is going to be pretty straightforward. So the first thing is we just have to build one of these things. So down here, I could do maybe like actor client in. And so I've got my actor client.live, but if we remember, this has a dependency on having a client, that's just the ZOHTTP client. So we got to get that from somewhere. So one option is I could just let this propagate up to the dependencies of this actor system. But at least so far, I've kind of been trying to hide the internal implementation here. And I think I'm going to continue that pattern here. So I'm just going to do server.default. It's just, sorry, not server, client, excuse me. Client.default is just the default client from ZOHTTP. And I'm going to send this into the actor client. So it's got what it needs. And then I'm going to build that. And I'm going to get it out. And I'm going to make sure to extend that into the scope of this whole layer here. So the client is going to stay open as long as this layer is open, because I'm going to have multiple calls to the client as I go here. So let's do this, see if this works. So it's not happy, and I think it's not happy because, so this can fail, constructing a server can fail with a throwable. This right now says it doesn't fail, so I'm just going to convert that into a die failure. Because if I can't even start the server, then I can't do a whole lot with my actor application. Okay, so now I've got a client, and now I think these things are going to be pretty simple. So here for send, I could just do actor client send, actor ID, message. And I think the only thing we have to do here that's a little bit tricky is kind of I know more about the type information of these schemas. Oh, well, so first all right, so we've got a little bit of an issue here. And the issue is basically that we don't at this point have a schema for this thing. Because last time we updated the make method to require those schemas, but we didn't update the unsafe make method to require those schemas. So I'm just going to fix that now. So I'm going to add these request schemas and response schemas to the type signature here and here. And then I have a little bit more information in the compiler. So I can say here, request schema as instance of schema, message. Let's see, what did I just track down this compilation error? Let's see. Oh, as instance of. Let's see, I need to actually use balance. There we go. Okay. So that is pretty straightforward. And similarly here, this can be actor client ask after the message, and this time we'll have the request and the response schemas. Okay. So now we've nominally done our first part of kind of implementing the client side. So now we need to actually create an example that's going to exercise all this functionality and actually make sure it works and debug it if we have any issues along the way, which we very well may, because we've obviously been doing a lot of things and we've not run any tests here. So we're going for the straight for the integration test. But let's think about what an example would look like here. So I've obviously only got kind of my computer here. So I think what I'm going to do is essentially I'm just going to create two JVM processes, and we'll just kind of assume one of them is each of these corresponds to kind of a node in my little system. And so I think what we'd like to do is we'll maybe take this same example here. We're just, I mean, pretty simple. If we just like create this actor and then we set its temperature and we got the temperature. And we'll just try to make this distributed. And so I think we'll have one node where we make the actor, and then we'll have another node where we're sending these messages, and we'll kind of verify that second node is able to send this message and then send this message, and the response that it gets back from this message actually reflects the state being updated here. So let's work on that. So maybe I'll call this node 1. And this will be another app. Oop, not two defaults. So again, I'm going to just import all the stuff from my example. And so I think this one can start off with a lot of the stuff here. So we'll still make the actor system, and let's say we'll make it localhost 8080. We'll make the temperature actor, but then we won't do this stuff. This stuff is going to be the responsibility of the other node. And so the only other thing we need to do here is we just need to stop this thing from shutting down because we need it to be up for anything else to happen. So we'll just basically wait until we just hit the enter key, and that way this server will be up and running here. And then our second node is also going to be an app. And this, we got to do kind of the other side of it. So let's kind of walk through what that looks like. So this one is going to start off, say, on 80, 81. And this time we need to make an actor, or we need to make a reference to the actor, but we don't actually want to make the actor here. We just want to make the reference. And so we've got a way to do that. We've got this unsafe make that gives you this actor ref. And right now, I think this is package private. Right now, just for us to kind of test this, I'm going to remove that so that we can actually call it from here. I will note this is definitely something where, like, if we did more work on this, we would want to build in like a way for an actor to kind of access a reference to itself, and then it would be able to pass it in a message it sent. But right now, we're just kind of trying to like verify this infrastructure is working. So we're going to use this unsafe make, and we'll kind of note that, like, obviously this is like not the, eventually we'd want other ways to do that. So here, now that I've got this actor system, I can do actor system dot unsafe make. And so I need to specify what the input and output types of this thing are, since I'm not actually defining a function like I normally would define this. And then I need one parameter that's this little actor, the location of it. And so if I go back to my unsafe make method, so this expects an actor ID. So let's do that. So let's just define a few things. So let's say location is going to be localhost 8080. So again, ideally, probably longer term, this is going to come from some information that's in the message that one actor is sending to another. But right now, we just want to test this. So we're just going to say we know that this actor that we want to call is on the other node. And we're going to create a local ID for it. Again, this eventually will be coming from somewhere else. But right now, we're just going to kind of do this test here. So we know this is the only thing running there. The actor ID is the combination of those two things. And so put that in here. And let's see. Oh, and then I just need to, because this actor ID is internal, I'm going to import my internal stuff so I can have that access to that. Okay. And so now I've got this actor, which, I mean, we kind of had to do some stuff to create it, but now as far as the user of this actor is concerned, this actor is just a normal actor that you don't know whether it's running on this machine or somewhere else. And so now we can copy all this logic from here and move it down to here. And so now theoretically, I should be able to start this up. As long as I don't press a button, this will keep running. Then I can start this up, and this should tell me the temperature was 42 degrees. Before I do that, let me just add a couple of like quality of life or debugging things to this as we go. So one thing that I think is nice is, why don't I add a health endpoint here? And then I can just implement that on my server. So I can just say val health, and I'll just say okay. And I can add that here. Let's see. Oh, did I just make that? Or maybe it's save. Oh, I just need a handler here. Handler. Okay. So now I've got the health check endpoint added. So that was super easy, and that'll be nice. Just make sure this thing is online. And then I'm also just going to add a little bit of debugging to the server here. So let's see, where we have actor system service. Okay, here we go. So I think I'm just gonna do something like zia.debug. And maybe I will say something like server received send ID actor request. So there's ask. And then maybe I'll do a debug here. Okay. That way, just if things are blowing up, I'll get some little bit more information on what's going on here. Okay, so I think we're set to try to run this example. Does anyone have any questions as we're going through this? Okay, so let's see, I got these two. All right, so first one, let's go back to our example here. Let's actually close some of these files. Okay, so let me run. I'm going to run my node 1. Okay, so it says press enter to continue. And now I'm just going to take 1 sec and I'm just going to hop over and I'm going to go to my little localhost 8080 health check. Let's see. Oop, yeah. Let's see. Let's make sure my health check is. There we go. Okay. All right, so I'm getting my okay message. So my server is up, which is great. And now here, oh, I think I just updated something. Okay. I'm going to run node 2. Okay, so I'm blowing up with some stuff. So let's go to my server here and let's look at what's going on. So, so we received the send. We sent a response to that. Okay, but then we had this failure here. We had a die exception that a get temperature cannot be cast to nothing. And this looks like here. Okay, and so this is one of those areas where we're kind of, we're taking responsibility for the type safety of some of this stuff. And so I think what is happening here is I think it's trying to cast this to nothing, even though it doesn't need to. So I think, let me try giving this a type annotation. Just say, look, we don't really know the type of this, it's just any. Let me just hit return here and get back to compiling this. Okay, and then I think we need to say this, then dot as instance of. I think that would solve that. Okay. All right, let's try that one more time. So let me make sure, okay, both these are done. Let me run this. Oops, I think I might have, okay. Oh yeah, I did press enter, which I shouldn't have done. So let me try that one more time. Run, 2, do not press any other buttons. Okay, all right, so we got our server running. And now let's try. Look at that. Okay, so we've now, on one machine, we've got this actor running. And on the other machine, we made a request. Well, first we sent it the set temperature message, and it did indeed set the temperature. And then we asked it for the temperature, and it gave us back the temperature. So we've got, obviously it's not industrial grade at this point, and I think there are definitely things we can improve. But we've got this doing what it's doing at this point. So I think that's actually largely what I had for today. I don't know, maybe I talked more quickly than usual, or we did fewer questions than usual, or maybe we're just at kind of the end of this. But I think there are definitely a bunch of kind of areas that we could improve it more. I think particularly kind of I think you'd want to have some concept of an actor being able to like access kind of its own context of like know its own ID so that it can set in messages to other actors. I think we could also look at kind of where we're requiring schemas and think a little bit more about like where that should be required. Is that a thing you do like when you send a particular message? Is that a thing you do when you define one of these actors? But I kind of feel like we've had a good number of sessions on this, and this is kind of a nice and cool stopping point, at least for now. Maybe we can go back, at some point in the future and kind of do more with actors. But I think this is maybe like a good milestone, just so people who want to have other things are not subjected to just like months on end of this thing. But yeah, I think it's been a really fun thing to do together, and definitely keep sharing ideas for other things you'd like to see. I don't know if Nabil is here today, but I know he had a suggestion for kind of like a migrating from like Akka HTTP to Zio HTTP that would be really cool. And maybe if he's suggesting, maybe he wants to come on and we can talk about that. But also always open to ideas of other things to kind of explore together. I think at some point it would be cool to like maybe build this out a little bit more, and then we could use this to do some other more like distributed like consensus type things. But I think maybe we should have like a little bit of a break before we do more of that. But yeah, always great to hang out together. Does anyone have anything else they'd like to cover before we call it a day here? I'll definitely push up the code from this so you can play with it yourself. And like I said, it's definitely like not perfect, but also kind of cool to see how you can do something somewhat real without like a ton of time with all the different tools we had. And hopefully it was good to kind of see how like the Zio HTTP and the Zio schema and there's the normal Zio, all this stuff kind of comes together. All right. Well, cool. I'm not sure if we're gonna do a session next week because I think it's like I think it's like Christmas Eve, so maybe not. But definitely, if not, then we'll be coming back in the new year, and yeah, have a wonderful holidays, everyone. Um, oh, so there's a question from Chris. That's an interesting question, and maybe we could come back to it at some point of the ZOHTTP discussion. But Chris asks, should a client handle flaky connections itself? I would tend to think not, just because there are different strategies you might have, right? Like what's the definition of a flaky connection? And like I mean, here I'm just retrying it forever. Like that's probably not the best thing. Like what backoff do you want to use? When do you want to give up? Like I tend to think that's um kind of a higher level thing you want to build on top of it. Maybe there should be some kind of tools for that as well. But I think that would be a cool thing. Maybe if we have Nabil sometime, we can talk kind of Zio HTTP design. But yeah, that would be, I guess, my initial thought on that. But yeah, definitely a great question. And have a yeah, like have a wonderful holidays, everyone. It's been great spending the year with you, and hopefully you've had a enjoyable year, and Zio stuff is at least somewhat positively contributed to that. So yeah, have a wonderful holidays, and hope you have a great time. Take care. Bye.